You probably talk to them almost every day, but have you ever stopped to wonder how they actually work? Well, today we're going to pull back the curtain and explain the fascinating and, frankly, kind of wild technology behind large language models.
So, let's kick things off with a little thought experiment. Picture this. You find a movie script, right? It's a scene between a person and an AI. You can read what the person asks, but the AI's part of the dialogue is just gone, ripped right off the page. So how would you figure out what it's supposed to say?
Well, you could use a machine that's just ridiculously good at predicting the next word in a sentence. You'd give it the script you have, it would make a guess at the very first word of the AI's reply, then you'd add that word to the script, and you just do it again, and again, and again, word by word. Now, believe it or not, this is pretty much exactly what's happening, just on a massive scale every time you chat with an AI. At its heart, it's just a really, really sophisticated prediction game.
Okay, so this next word prediction machine, what are we really talking about here? What is it, technically? Well, it's time we gave it its proper name. It's called a large language model, or as you've probably heard, an LLM. And deep down, that's all it is. A very complex mathematical function that does one thing. It predicts the next word. But how it does that involves a really clever little twist.
See, here's the trick, and it's what makes them feel so creative. An LLM doesn't just pick the single most obvious word. No, instead it looks at all the words it knows and assigns a probability score to each of them. Then it kind of rolls the dice and picks one based on those probabilities. And that is why you can ask the same question 5 times and get 5 slightly different but still perfectly good answers.
Right, so how does a machine get so good at knowing the probability of every word in the English language? Well, the answer is training. A training process that happens on a scale that is genuinely hard to wrap your head around.
The best way to think about an LLM is like this giant machine covered in tiny little dials. Not thousands, not millions, but hundreds of billions of them. These dials are called parameters, and they control everything the model does. Training isn't about a person writing code, it's an automated process of tweaking every single one of those billions of dials until they're in just the right position. Now, to tune all those dials correctly, the model needs to learn from data. And we're not talking about a lot of data, we're talking about a colossal, almost incomprehensible amount of text. To put it in perspective, if you decided to read all the text used to train a model like GPT-3, reading 24/7 without a single break, it would take you more than 2,600 years.
Yeah. Okay, so the data is huge, but what about the actual number crunching? The sheer math required to tune all those billions of parameters? Let's imagine a supercomputer of a person, someone who could do a billion calculations every single second. How long would it take them to do the math for the training?
The answer is just staggering. It would take that person well over 100 million years for one training run. The scale we're operating at here is it's beyond human comprehension, really.
So what does this monumental process actually look like? Well, believe it or not, it's a very simple loop that just gets repeated trillions of times. You show the model a sentence, but you hide the last word. The model guesses the word. You compare its guess to the actual word. And then, using a clever algorithm called backpropagation, you go back and make tiny, tiny adjustments to all those billions of dials, just to nudge it a little closer to the right answer for next time.
Okay, so being able to perfectly complete sentences from the internet is one thing, but that doesn't automatically make you a helpful and safe AI assistant, right? That takes another absolutely vital step in the training process.
You can really think of it as a 2-stage process. First, there's pre-training. That's where the model just swallows the internet whole to learn grammar, facts, and how language works. But then comes the really important part, reinforcement learning with human feedback, or RLHF. This is where actual humans come in. They rate the AI's answers, they flag things that are unhelpful or unsafe, and they basically teach the model the nuances of being a useful tool rather than just a text machine.
Now, everything we've talked about, the trillions of calculations, the mountains of data, none of it would be possible without a revolutionary breakthrough that happened just a few years ago. It completely changed the underlying architecture of these models.
Before 2017, the models had to read just like us, one word at a time from left to right. It was slow, it was inefficient, and it really limited how big they could get. But then, in 2017, a paper introduced a new architecture called the transformer. And the transformer could process all the words in a sentence at the exact same time. It could look at the whole thing at once. And that single change was the key that unlocked the modern AI era.
So what's the secret sauce inside the transformer? It's a brilliant concept called the attention mechanism. It basically lets every single word in a sentence pay attention to every other word at the same time. This is how it understands context. It's how it knows that the word bank means something different when you're talking about a river versus when you're talking about money. It's looking at all the surrounding clues to figure out the true meaning.
So we've covered the data, the computation, and the architecture. But maybe the most surprising thing of all is the result. The incredible abilities these models have, like reasoning or writing computer code. Well, nobody ever actually programmed them to do those things.
This is the key idea right here. These complex skills are an emergent phenomenon. They just appear out of the very simple task of predicting the next word once you do it on a massive enough scale. Nobody ever sat down and coded an explain a joke module. That ability simply emerged from all the patterns the model found after analyzing trillions of words. And this emergence leads us straight to one of the biggest challenges in AI research. We can see that the models work. Their output is often brilliant, but it's almost impossible to peek inside at those hundreds of billions of parameters and understand why it chose one specific word over another. It's a black box, and we're still trying to figure out how to look inside.
And this all leaves us with one final, pretty profound question to think about. These models are trained on a vast digital reflection of us. Our stories, our conversations, our knowledge, our flaws. They learn by predicting what we would say next. So when we see this strange new form of intelligence start to emerge from our own words, what is it ultimately telling us about ourselves?